This is about graphing exponential functions, and so we talked about this before spring break about how to graph an exponential function, and I believe the example we looked at was f of x is equal to 2 to the x. And so we plugged in values and got an idea of what this would look like, but basically these are the things that we said about it. We said that it has a y-intercept at 0, 1, and that this graph has a horizontal asymptote at y is equal to 0 at the x-axis. So this is the y-axis, this is the x-axis, and this is the y-axis, and that it hugs the x-axis over here, and then it slowly starts to increase, and then it takes off pretty quickly, exponentially. It starts to increase. And we said the domain of this guy is from negative infinity to positive infinity. The range is as close as it can get to 0 without equaling 0 to infinity. We said that this is a one-to-one function, meaning it passes the horizontal line test and it has an inverse. We said that it's an increasing function, and this is the horizontal asymptote, and that it's got this intercept at 0, 1. And all of these little statements that we made, that it's one-to-one, that this is the domain, this is the range, this is the y-intercept, and this is the horizontal asymptote, would be true for any exponential graph of the form f of x is equal to a to the x, where a, the base, is greater than 1. All of these things same statements can be made for a function that is where the base is bigger than 1. So you have a worksheet to follow along with this video where we go through these graphs, and so we're going to look at 4 examples, and the first one is we're going to graph this, and this will go pretty quickly. The first one is let's graph f of x is equal to e to the x. And so if you will recall, e is a button on our calculator. It's a number. It's approximately 2.71 with some more digits after that. But 2.7 is a number bigger than 1. So it fits in this category. So all of these same things can be said about that. So the graph of e to the x will look like, we're doing a sketch here, but it's going to have an intercept at 0, 1. It's going to hug the x-axis, and it's going to cling to it, and then it's going to increase like this. It's going to have the same horizontal asymptote, y equals to 0. It's going to have the same intercept 0, 1. It's going to have the same domain, negative infinity to positive infinity, and the range will also be from 0 to infinity. And so on the little sheet it says, what is the domain? We have that. What is the range? We have that. It asks for an x-intercept. There's no x-intercept. No x-intercept. It asks for a y-intercept. The y-intercept is at 0, 1. It says, what is the horizontal asymptote? This is the horizontal asymptote. And then it says, what is the vertical asymptote? There is no vertical asymptote. So those are the questions we had to answer for number 1. Let's look at number 2. And these are simply transformations of this, our basic graph. So number 2 says this. State the transformations and answer the following. So to part A says f of x is equal to e to the x minus 2 minus 3. Okay, let us consider this. What are the transformations? Well, if the basic graph is just e to the x, and we look at this, we have e to the x minus 2. This minus 2 is in there messing with the function, so this is a horizontal shift. So this means it's going to go to the right 2. Minus 3 is just tacked on the end. That's a vertical shift. It is what it appears to be, so that's going to be down 3. That's the transformation. So let's sketch this guy. All right, the origin is going to get shifted right 2, down 3. So if we go right 2, down 1, 2, 3, this is our new origin, so to speak. So, right, that means this is going to be my new horizontal horizontal asymptote. Not at y equals to 0, but y equals to -3. That means this point right here, 0, 1, will occur 1 unit up from where my new origin is. And so this is what my graph is going to look like. So if we need to make some statements about this, let's call out what is the domain. The domain for this guy is -infinity to +infinity. The range is as close as we can get to -3 without touching it, to infinity. Let's see, is there a horizontal asymptote? This is the horizontal asymptote. And let's see, what else does this ask us to do? What is the y-intercept? Well, the y-intercept is where x is 0. So we can figure that out, but we'll do this once and then we won't worry about it anymore. Where is the y-intercept? Well, that is where x is 0. So let's see, what is f of 0? Let x be 0 and solve for y. That would be e to the -2. 0 minus 2 is -2 minus 3. So 0, comma, e to the -2 minus 3. That's what this point is right here, the y-intercept. They have it on the sheet, but I'm not going to keep asking that because don't worry about that. I'm interested in this, and this, and this, and the graph. Okay, let's do the next one, which is C to C, and it asks us to graph this. F of x is equal to -e to the x. So let's put that guy up there. F of x is -e to the x. This is is this C or B? What am I doing here? Oh, let me do B next, sorry. B is f of x is equal to f of x is equal to e to the -x plus 3. So what transformations are taking place here? Well, we have a reflection. A negative always indicates a reflection. This negative is not in front of the basic graph. Remember, the basic graph is e to the x. So this is the basic graph. In front would be a negative in front of the e, but that's not where the negative is, in front of the x. So that indicates a reflection. This reflects across the y-axis. This plus 3 on the end is a vertical shift. It means it's being shifted up 3, up 3. So we're going to take the basic graph and reflect it across the y and shift it up 3. So this is what this guy's going to look like. Here's my xy axis. It's going to be reflected and up 3. So if we go up 3, 1, 2, 3, and reflected, if it gets shifted up 3, then this is my new horizontal axis. But instead of having this shape to it, it's going to be flip-flopped across the y. That means it's going to hug the horizontal asymptote here and take off like that. That's what this one will look like. The domain is still -infinity to +infinity. The range is from, this is 1, 2, 3, is from 3 to infinity. The horizontal asymptote is y is equal to 3. The y-intercept, this one's not too hard to find. It's 0, 4. Okay, that was 2 part B. We have one more to do, 2 part C. Let me see if I got a better marker in here. I have a purple, maybe it will be a good one. Let's see, 2 part C is f of x is equal to negative e to the x. Okay, this is the basic graph. So the one thing that's going to change here is a reflection. This negative is in front of the graph, meaning it's going to reflect across the x. Reflects across the x-axis. So this guy will look like this. It's this basic graph, but it's reflected down. So this is still the horizontal asymptote. So instead of the intercept being here, it's going to flip down to here. Instead of it hugging right here, it's going to hug right here. So this is what this guy looks like. Down like that. His domain is still -infinity to +infinity. The range is very different, however. It's from negative infinity all the way up to 0. This is the horizontal asymptote, and the y-intercept is 0, -1. So that are some examples of exponential functions. Okay.